Hello and welcome everyone to DevSecOn Germany. We are live again today with the virtual session of our meetup series. And well, first of all, what is DevSecOn? So DevSecOn Germany is part of our global community. We have around 20 chapters worldwide, and it's all around educating and enabling developers in application security. And today we are joined by Andrew Holloway, who's talking about investing in people and driving rapid change with skill sprints. And before I hand over to Andrew, and first of all, a quick intro about myself. So I work at Sneak as a technical pre-sales for the DACH region, and I'm joined by my co-host.
Hi, I'm Seb, and I work as a tech specialist also at Sneak. Nice to meet you all.
Excellent. Yeah, so first of all, this will be an up to an hour session, nice lunch and learn session. We, of course, love your feedback, right? So if you have any feedback on the content or how we deliver it, technicalities, please follow us on Twitter, and also follow us on or subscribe to our YouTube channel. And then also maybe some words on how people can interact with the speaker.
Right. So this is your session. Keep it as interactive as you like. Our YouTube channel is the best place to drop your comments, and Andrew will weave them in and hopefully address them. If you have questions afterwards, we have a Discord channel. Find us there in the DSC-Germany channel, and all of your questions can be answered there. You can discuss with Andrew, discuss with other members of the community. And after the session, feel free to share it with your friends and colleagues, hopefully both. And hopefully you'll get a nice value out of this one. Thank you.
Great. Yeah, so DevSecOn is brought to you by Sneak. It's a vendor-neutral space where we like to share the knowledge with other practitioners from every region. That's why also we keep this session often in English. And that's about it. So first of all, I want to welcome you, Andrew. And maybe if you haven't done it in your slide, maybe introduce yourself really quickly. What's your background, where you're coming from, and then I
do have a slide, but I'll go straight to it. So basically, I started my career in supercomputing. I ended up in Germany working for various research establishments in Hesse, doing large-scale supercomputing, which then ended up me doing a bunch of stuff for the Large Hadron Collider, which I'm still quite smug about. I'm my core really an infrastructure specialist, but I also do pretend to be a Python developer, a fairly mediocre developer at that. I have failed as a CTO, and I'll probably fail again, but I have been working as a technical consultant for years. And for the past 4 or 5 years, I've been really getting into instructional design, and that's really been about, as I've become a senior engineer, I think one of the key things that a senior engineer should be able to do is to be able to effectively and efficiently build knowledge within teams. In fact, I think that's probably the most important thing that a senior engineer should be able to do, and I think it's often overlooked. So Darwinist is a company I set up 2-3 years ago. That's kind of, it's not really gone great. The clients, so in terms of, and I'll get into that, I'll get into why. So we set up the company with the intention of delivering skill sprints, which is what we're going to talk about today. But one of the problems with skill sprints is that, so there's when you do traditional consulting, often you're not really solving the problems of your customer. You have opportunities to kind of like drag things out a little bit. And I was like, well, we can really solve customer problems. But the problem is when you really solve customer problems, they don't need you anymore. And therefore, it's not a great business model. So anyway, instructional design, I mean, you can read, I'll read it for you. So basically, instructional design is really about designing learning and designing learning outcomes. This is often really difficult to do within technical spheres because of the type of knowledge. So technical knowledge is what we call tacit knowledge. In German, this is stilles Wissen. And this type of knowledge is very, very difficult to disseminate via the written word via spoken. It's really experiential. You have to have hands-on experience with doing it. In the same way that you could read 100 books on carpentry and you could be married to a carpenter for 50 years, that doesn't really make you any closer to being able to make a table. And it's kind of the same with software development. And we've seen people going through boot camps, for example, and they sort of land into the workspace with not really much idea of how to contribute to a software development team, because everything's so contextual and tacit. It's really difficult. And this is the problem space that I've been really focusing on over the past few years. So the way I work typically now is as a learning objective. So, for example, a client may want to get to grips with Kubernetes. So then what's the objective of that? Well, the objective is going to be some of their engineers, 1, 2, 3 of their engineers, is going to be proficient in operating their application on top of Kubernetes. Where we get Kubernetes from, that's another problem. But they should be able to manage the life cycle of the application on top of Kubernetes. It's not just a case of doing a course. You can't take a software developer, bung them through a course, and then expect them to be able to deliver something worthwhile to their organization. That doesn't really work like that. And we all know training budgets, and somebody's gone off and done a training, but then they come back from their training and then they've got like a backlog to get through, and then suddenly it's like, oh well, yeah, Sally did this training course, maybe she knows something about it, and then of course Sally forgets everything almost immediately. And this is the real pain with technical learning, is that it has to be experiential. You have to do it in your job. You have to be hands-on. You have apprenticeship schemes which are very, very good at building this type of tacit knowledge, but this doesn't exist within the IT sphere, within the software development sphere. It doesn't exist at all, actually. And as such, juniors are often being overlooked. It's quite difficult. So most software development teams, technical teams, they're very, very good at working within what they know, working within the technology stack that they know. So we're developing an application, we're using Postgres, we're using Python, maybe there's some Redis, blah, blah, blah. We as a team are able to create new features, we're able to create new value for our organization based around this cluster of technologies that we already know and we're using. We can add new business logic to that. But if you ask the same team to do something left field, like for example, it's like, oh, well, Python doesn't work because we can't really multi-thread with Python, therefore Golang. Getting that team to be able to effectively and efficiently switch over to using Golang is nearly impossible. And this is the kind of space that I've been working in. If you find out that a technology is lacking, how do you quickly and efficiently switch over with a minimum amount of fuss? So Agile as a methodology, it only really works when we've made our choices and we're working. So, you know, we've chosen Python, we've chosen Postgres, and we know what we're doing with those technologies. We know how to make features. But you can't really do Agile when it comes to selecting technologies. You can't really, you know, everybody knows when a new project is starting, the weird mess, which is just people getting to grips with the tooling, people trying to understand and trying to decide what technologies to use. You can't do Agile with that. Agile only really works when the technology choices have been made and you're ready to start making features. Who needs a product owner when you're deciding what database to use? It's very, very difficult to manage these starting phases, these technology decision phases. So typically when you have a technology team and they realize that their current stack is lacking something, often a single engineer will be sent off, go and do a research spike, go and find out what you can, and then from the basis of your understanding, then we can then make a decision. But this is really, really, like, I've been in this position myself, and it was very, very weird. They're like, oh, well, what's our way forward, Andrew? How are we going to solve this problem? What technology we're going to use to solve this problem? And this is really exposing. So I've had like maybe a little bit of time to do a bit of preliminary research on a technology. I'm probably quite junior, maybe, because you probably, I don't know if you spend your most expensive and most experienced talent on doing a research spike. And then suddenly you have to make, as a team, you have to make a decision based on the findings of a single engineer with how much experience. It's very, very difficult, and it's very, very exposing for people. And I think this ends up with an awful amount of weird deadlock, and generally results in things just not happening. Yeah, and that's very, very tricky. And again, it's just established technology teams are bad at doing new things. They're good at doing things within the world that they know, within the technologies that they know. But then when it's time to do new stuff, problem. Patterns are really important in technology, like really important. You can use technologies in many different ways, but generally the designer of a technology, the developers of a technology, have one or two quite narrow intended purposes. You can use this big data database as a transactional store. So, for example, you can use MongoDB as a transactional database, but you're going to have problems down the line when you try and do that. You can do it, but it's not really intended for that. You can use SQL Server as a big data platform, but you're going to start hitting problems at some point. And so understanding what those patterns are takes quite a lot of work to understand what's the intended use of this technology. What is the pattern? How do we use this? And Kubernetes has really shown this, and Kubernetes has really shown the sharp difficulties of introducing a new technology. So when Kubernetes rolled out, what was it, four years ago, I think, it was very, very difficult. Nobody really knew how to use it. Everybody was like, oh, do we use Helm? Well, like the first time I touched this technology was with Helm, therefore that must be how it works. And how do I architect my application for containers? And oh God, now we're doing microservices, and nobody really understands how all of that. And it resulted in some really exciting and very interesting messes, which I have the pleasure of clearing up to this day. And so finding this pattern is incredibly important. And again, if we go back to a research spike, you're asking a single engineer, maybe two engineers, if you're lucky, to find and understand an effective pattern for introducing a new technology that's probably going to be business critical. It's a problem. It's very, very difficult. So basically, skill sprints. I came up with this. I was actually working on Kubernetes. I didn't want to. I was very, very anti-container. I was very, very much, salt stack and Ansible and systemd is the way forward. And I got a lot of experience in clusters, and so anything that is a cluster, I'm incredibly, usually very, very suspicious of. But I was kind of forced to do it. I was working with a client, and they were like, well, we really want to do Kubernetes. And I was like, I really don't want to do Kubernetes. And they're like, that's exactly why I want you to do it. And I was like, fine. And I was very, very happy that my first experiments with, or the first setup of Kubernetes that I inherited was a disaster, because it was based on COPS, which is a self-managed open source distribution of Kubernetes that was deployed onto Amazon Web Services, and it was a mess. It was a wonderful mess. It was just a complete disaster, and it was very expensive as well, because you've got to manage COPS, but also you've got these very expensive servers from Amazon that you have to pay. It was really a disaster, and this was before Elastic Kubernetes Service from Amazon turned up, which is a semi-decent solution. Anyway, so I had experience with Kubernetes, and then my next project, they were also, we want to get into Kubernetes. And I was like, okay, great. And they were like, so how long is this going to take? And I thought about it, and I was like, well, it's probably going to take about a week, because your application's already, your application is already Dockerized, because you're using Dockerization with Docker Compose in your development environment. So we know that works. And then it's just a case of writing some schemas, application schemas for Kubernetes. And the person that was hiring me was like, that's not possible. That means I'm going off on a holiday and I come back and everything's been taken care of. And I was like, and I was thinking about this, and I was like, this doesn't sound right. In a week, this is crazy. But it really was delivered in a week. And what was really incredible about that is that I didn't touch a keyboard. I was working with Daniel the entire time, and Daniel was their permanent employee. I was just a contractor. And Daniel did all the work. I sat with him and we put the entire thing together. We worked with some other developers when required, and literally in the space of a week, it worked, and they had something that was actually really working. And then Daniel was able to go live with the entire thing a couple of weeks later. I was nowhere near. I was out of the picture by the time that they went live. They decided themselves to go live. I wasn't anywhere near, and that was very, very powerful, because that gave them the ownership of everything. And so I started thinking, oh, that's really crazy. If you can really do things in the space of a week, that's crazy. And it turns out that for introducing new technologies, for doing certain transformations, you really can bash it out in a week. And in fact, now I'm starting to have the feeling that if you can't do something in a week, and if you can't reach some kind of goal within a week, are you really sure what you're doing? And I've been involved in these really sort of long-arching transformation projects where everybody's a bit confused about what's going on. Everybody's flinging mud at it. Yeah, no, and so basically this skill sprint methodology sort of came out of my experience of like just doing things quickly, basically, and then I kind of formalized it on how it should work. So I also do, so along with skill sprints, I also do capability cultivation. So some organizations, they're kind of like going through more of a discovery phase. They're trying to work out how to work with a bigger constellation of technologies. So for example, I'm running a capability cultivation around an organization that's trying to get to grips with streaming data, Lambda architectures, with things like Amazon Kinesis. And so this is a much longer, I'm also having to learn quite a lot as well. So this isn't really a quick, okay, we know what we're going to do. We know the technology pattern, bash. This is more about if there is no established technology pattern for it, how are we going to put this together? But this is also hands-off, so all of the work has to be delivered by the client, and because then they have ownership of things. And so with both skill sprints and capability cultivation, this is really, really about building ownership within the organization. And it's about me being able to disappear and then being in a safe, secure situation with this new technologies or new set of technologies. As well, when things go live, I mean, we prove that they have ownership as well, in that when things go live, I'm generally not in the room. And then people have made the decision to go live, they're comfortable going live with it, and they're able to do it without me being around. And then it's their win, which is most important. So training is very, very difficult within technology organizations. I touched on this earlier. So over here, we've got the, I don't know if you can see, but in the top right here, we've got this forgetting curve. So you can see that when we learn new information, we've already lost 20% of it within the first day. And then this just gets worse and worse and worse. Like, and I think that even this graph is rather optimistic. Whenever you're trying to learn new things, so for example, when people learn new languages, maybe they'll do an evening class once a week. The thing is, after a week, you've lost so much of what you've learned that you're pretty much starting from scratch again. I've got a friend of mine who's learning to drive, and she's in her late 30s. I don't know if that really makes a difference, but she's learning to drive. And we were talking about the way that she was learning, and she was doing 2 lessons a week, an hour on Tuesday and an hour on Friday. And I was like, well, why don't you just put those 2 together? Then you'll really double up. And she really did. When she put those 2 hours together, she radically improved. And then I was like, well, if you're learning to drive, wouldn't it be better just to be driving, just take a week off work, just drive for 4 hours a day, and then, you know, you'll be able to drive, because you're building on top of experience. You're building on top of what you've just learned. But if there's a gap of time between each learning, you lose it so fast. And training as well within the technical field is always a massive problem. You go off and do a course, but the thing is with technology, technology is incredibly contextual. And again, other engineering spaces, so for example, the aviation industry, the construction industry, and especially in Germany, the way that apprenticeships are run is fantastic. You have students that have a little bit of college, lots and lots of hands-on site work. And as well, like when these students are working on site, they have really good quality interactions with senior engineers. It's really well managed. And this is also quite well regulated in Germany as well, in what an apprenticeship is. And there's a lot of respect for the young person's time, which is unbelievable. We have a bit of this in the UK, especially in the aeronautical space. Apprenticeships are still very strong there. And it is coming back in the UK in quite a strong fashion now. Vocational education is getting much better here. But Germany, unbelievable for this. But in the IT sector, it's a disaster, and it really isn't. Like, these poor people go off and do these boot camps and then suddenly thrown into an organization that isn't prepared to teach them, that isn't prepared to apprentice them. And then, yeah, so it's a mess. It's really, really difficult. And training is especially difficult as well. Trying to learn things with no context, without the context of what you're doing within your organization is really a disaster. It's very, very difficult. So, yeah, consultants. So I've had experience with good consultants and I've had experience with bad consultants. And it's very, very difficult. When you're outsourcing something, there's always going to be interesting problems. I've worked for organizations like Deutsche Bahn, and that was extremely difficult because there was a lot of consultants running around with very little oversight. They had very, very broad scopes as well. They're just running around billing huge amounts of cash for I don't know what. And I've seen this as well within government projects. I've seen this within government projects within Germany as well, where you had one of the big consulting houses coming in and just really destroying the organization, supplanting their people within the organization, and yeah, doing some really, really strange stuff, and not building ownership. They were essentially, if I was being, I think that many consultancies and many of the big consultancies, what they're really trying to do is breed dependency. Because when you have your client dependent on you, obviously you can bill them a lot more. And I think, well, I definitely discovered this setting up Darwinist, is that when you satisfy the customer requirements, suddenly you have a business development problem. So I think for the consulting houses to stay in business, they have to build dependency with their clients. And I'm not sure that all of them find a good balance with that. So if you're using consultants, be very, very careful. I think you can, if you use consultants in the right way, but it's going to be on you as the consumer of a consultant, how to use them and how to design that interaction. Is that consultant coming in as some kind of employee, some kind of like third-party resource? Are you pulling them in as an educational resource? Do they know how to educate? Do they understand how to deliver knowledge? And so I'm pretty confident when I say that the relationship between clients and consulting is very, very broken. My attempt to fix it resulted in a failed business, so or a nearly failed business. I still haven't quite failed it off. There's still a trickle of clients coming through, but it is a really when you want to work with external people, it is really, really challenging to find a healthy working relationship with them. And knowing how to define that relationship is really, really difficult. And like, what are the outcomes? What are the inputs? What are the outcomes? What's their role going to be? It requires a lot of thinking, and not everybody has experience in how to think about that. It's very, very difficult to work effectively with consultants. So this is a case study about one of my customers based in Nebraska. So running since 1976. They've been building an ERP system for the construction industry. They're based on a system called Progress. They're mainly based on a system called Progress Open Edge, which is getting a little bit long in the tooth. And they've been trying to get into Kubernetes for their new stuff. So they're creating a bunch of Go services, a bunch of new front ends to sort of move things away. And they were really struggling with Kubernetes. They just couldn't find good help on the market. There were organizations saying, yeah, well, you can pay us $20,000, $30,000, we'll come and chat to you for that. And it's not really, I mean, all of their services were already Dockerized, and they had quite a clear architecture of what they wanted to do. And people were saying, oh, $20,000 just to come and have a chat. Yeah, no, they basically could only do deployments from a manager's laptop, which was quite good. And yeah, this was really, really easy fixable. So we took 3 of their developers, and in the space of literally 3 days, we had them up and running. They were also trying to run their own Kubernetes based on top of VMware. I can't remember what distribution they were using. And this was also very, very difficult to manage and very annoying. And this was also something that they didn't want to really be doing. And that was creating some internal tensions from the from the infrastructure people to the developers that wanted to use Kubernetes. This was creating some tension. In the space of 3 days, we got something working in Google, and then the organization decided that they would just go ahead using Google, just using Google, using GKE. And very, very quick, very, very easy. They've been struggling with it for a long time. Yeah, and within 3 days of a skill sprint, everything was up and running, because it was really just a case of them, again, finding a pattern. And this is what they've been looking for ages, was just a simple pattern for how to use this technology. And once you have that pattern, it's no work. That's the entire point. Once you know how this technology should be consumed, it's no work. If you right now are 6 months through some kind of Kubernetes transformation, something's probably wrong. It's not that hard. And if you know how it should be used, it should be very, very, very quick and very, very easy to get things moving with it. So this is just, now I'm going to sort of go into sort of a stream of consciousness, just some sort of nuggets, some things that I've picked up along the way. So this is really for Amazon Web Services. So Amazon Web Services provide you with, I'm quite rude about Amazon Web Services often, because I think they do half the job for you. So I spend a lot of time comparing. I work a lot with Google, I work a lot with Amazon Web Services. So I work a lot with Google Cloud and Amazon Web Services. And so with Amazon Web Services, you often have a lot of stuff that you have to do, but we'll get on to that. But anyway, so basically the way that I'm setting up infrastructure platform within organizations looks like this. So we have a developer role, and those developers are responsible for everything inside Kubernetes. I don't know if I can, do I have a way of, no, I don't think I have a way of having a pointer. So we have in the middle here, we have some storage. This is going to be some stateful stuff. And then we have Kubernetes. And so Kubernetes is provided by infrastructure, but it's consumed by, so it's provided by a platform role, but it's consumed by a developer role. So that means that the developer are responsible for everything running inside Kubernetes. They're going to be responsible for the application containers, for the lifecycle of their application. They're going to be responsible for the CI/CD to get their application into Kubernetes. And the platform role are just there to provide a stable Kubernetes environment, a stable database environment. And so essentially you can think about databases, you can think about Kubernetes as a kind of a similar kind of thing. They have a schema, we have a database schema, and now we have with Kubernetes an application schema. And that schema is normally expressed in a bunch of YAML. And so developers are fully responsible for the schema of their application, for the schema of their database. And that's quite a simple demarcation. The platform role are then responsible for providing Kubernetes, for providing databases that are then consumed by the developers. And that could be in Google Cloud, in Azure, in Amazon Web Services, or even on-premise. A lot of people are going back to on-premise because it turns out that it's a tenth of the price of Amazon Web Services. And that's an interesting journey that some people are going on now. So talking about complexity, and this has been an interesting trend. I think it's kind of petered out now. But previously, so back in the day when I first started working, we had on-premise monoliths. And so this would be a massive bunch of PHP that was running on a couple of web servers with maybe a database backend, quite simple, quite heavy. And we can say that this system with a web cluster and a database has a complexity of X. And then we start getting to Amazon Web Services, and some of the complexity is managed for us now. So we can do auto-scaling very easily. Suddenly we don't have to take care of a database. RDS is a very, very good service. It does work incredibly well, and it just works. So that suddenly we're freed up for having to do database administration. We're freed up thinking about how to do failover and stuff like that. We don't have to think about it anymore because everything is auto-scaling. So we have auto-scaling working out of the box. We've got, I mean, it was a terrible, terrible, terrible thing, but it did work, which was Beanstalk. But they did work. they did operate, and if you could get them working, they worked very, very well, and they're incredibly reliable. And so the amount of complexity that we could put into our applications went up to X squared. And it really was a square in complexity because of all of this system administration stuff that we just didn't have to do anymore. And then we get into Kubernetes, and then suddenly we've got an X cubed complexity because now we're into microservices. We're into queues. We're having lots and lots of complex services intercommunicating with each other. We're having often multiple databases. We're having all kinds of wonderful things that are really easy to do because we have Kubernetes. If you were to try and do a Kubernetes, if you were try and do a microservices type architecture without Kubernetes, doing it on premise, that's going to be impossible. I mean, people do try and do it using sort of proprietary Amazon Web Services stuff, but it's a disaster. I mean, you kind of get it working with Lambda functions, but then it's expensive and weird. And so this is just how complexity of our application environments have exponentially increased over literally the past 15 years. So now, yeah, we're handling a cube of the complexity that we were handling 15 years ago. I always advise my clients to radically reduce Amazon Web Services footprint where possible. And so this is really, so, you know, if we can handle a complexity of X cubed in microservices, so if we can handle X cubed complexity in Kubernetes, Kubernetes is designed for handling lots and lots of complexity. Why are we doing anything in Amazon Web Services where it's very expensive and difficult and annoying to manage things there? And it is annoying and difficult to manage things on Amazon Web Services. So Amazon Web Services is mostly instruction driven. So when you're setting up things on Amazon Web Services, you've got to do this, then this, then this, then this. It's a very, very imperative programming flow. But Kubernetes is schema driven, it's declarative. Give me something that looks like this Kubernetes, and that's what you get. There are some imperative bits and pieces in there, but not really. And when you're thinking about where to put things, and when you're designing infrastructures, think about the imperativeness and declarativeness of the infrastructure where you're putting your applications. And it, as a rule of thumb, it's generally better towards the more declarative side of things. I'm very, 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 very mistrustful of Terraform. Not since HashiCorp changed the license as well, and that made everything really, really interesting. And generally, I'm not really understanding why people are using Helm. Helm's very useful if you want to distribute if you want to distribute your application. However, it creates a lot of complexity for not a lot of value. It's a little bit tricky. Oh yes, and please, if you've got any questions, if you want to flag a question, I'll get them straight away, and I'll try and answer them as we're moving along. If we go back and if we do radically reduce our Amazon Web Services footprint, then we can, what's left, the little bit that's left, we can handle it with a little bit of AWS CLI. We don't need to bother using third-party tooling such as Terraform. And I mean, you don't really need to bother, normally you don't really need to bother with Helm, but some people really want to cling on to it. So Terraform is an attempt to make Amazon Web Services declarative. And this is a classic lipstick on a pig type thing. I'm always very, very confused why, I'm using this very expensive, and Amazon Web Services is incredibly expensive compared to providers such as Hetzner or OVH, or it's times 10 expensive. So then why do I then have to use third-party tools to manage Amazon Web Services? Why doesn't Amazon Web Services provide me with these things? Why is this even required? Even for their Kubernetes project, even for AWS, for the AWS EKS Elastic Kubernetes Service, I still have to use a third-party tool to manage that called EKS CTL. Why doesn't Amazon do that for me? Why do I have to do that? Why do I, Amazon's very, very expensive. Why do I then have to put the energy as an organization? Why do I have to then invest in this whole third-party tool chain? That still doesn't make any sense to me. If I'm feeling particularly uncharitable, I'd say that this is Amazon Web Services' way of doing vendor lock-in, but you have to make your own judgments on that. This is just a little snippet and this is basically a really, really quick and easy way of deploying things on Amazon, deploying things on Kubernetes. So basically, we have here a bit of YAML, and basically, you can see here we're doing this env-subst thing. So env-subst is a magical tool when you're working with Kubernetes, because it means that you can have a flat file, and you can see this up there in the top right-hand side. We've got some environment variables in there. So basically with env-subst, it basically templates environment variables into your flat files. And this makes, you don't need any Helm, this is just a very, very simple. There are also other simple templating methodologies that you can do, but it's this simple. Generally, you don't need to use, you don't need anything more complicated than that. Yeah, for Kubernetes, env-subst is really life. It's fantastic. You can, on GitHub, please excuse the state of my GitHub. I've been terrible at maintaining it. You can actually find a simple pattern for doing Kubernetes deployments there. And yeah, you're welcome to have a play with that and get that working. I would advise when working with Kubernetes to really avoid using tools. Get your fingers into the YAML, understand what those YAMLs mean, and really get close to the cluster. Kubernetes was designed to be directly consumed by developers. You don't need some abstraction layer. I've never ever seen a situation where any of these abstraction layers or management layers have ever been really necessary. They just add complexity. Often they're just adding some vendor lock-in. They're obscuring the real platform from developers. Avoid them at all cost if you can, because they're generally not adding any value. So yeah, DevOps consultants and people who, it's very, very tricky. I worked as a DevOps engineer for quite some years. I started in high performance computing infrastructure and then sort of got into the sordid world of Amazon Web Services. And it did used to be it was a horrible job, but it was a real job. And you'd be grinding all kinds of tooling to try and get Amazon Web Services to work. And it was weird and horrible. You'd be using these configuration management tools, Salt Stack, Ansible, and so on and so forth, and various other bits and pieces to try and deploy infrastructure. Terraform, just a weird mix of tooling. And even then it was impossible because you had to have a way of keeping a process alive and monitoring the process when it was dying and knowing why it was dying and how it was running out of memory and so on and so forth. The thing is that with Kubernetes, literally 95% of all of this just disappeared. Kubernetes manages your process for you. So if it does run out of memory, it kills it, starts a new one, and you know why it died. And yeah, you can write with Kubernetes, you can write really bad code, really buggy bad code that runs out of memory every 45 seconds, and it will still work perfectly because Kubernetes will kill it and restart it, if it's misbehaving. So basically all of this DevOps work evaporated. But there are still people kind of really like clinging on to this role. And you've got to be a bit wary of that. If this DevOps thing is still a thing and you've got a lot of people working on it, you've really got to consider what you're doing, because it's very, very rarely necessary. It is necessary if you're working on a cloud provider, if you're working on Amazon Web Services, Google Cloud. I mean, to some extent, Azure, maybe it's still required. On major cloud providers, you shouldn't really have this as a standalone role. It shouldn't really be a job. But if you are doing deployments onto bare metal, if you're running your own Kubernetes clusters, for example, then it's something that you'd probably want to have as a separate job. But the DevOps role itself generally abstracts things away from the developers, which results in problems when you're trying to do things like microservices. And again, if you're still doing DevOpsy thing after a month, yeah, so keep it very simple, and yeah, you should be done very, very quickly. So yeah, getting back to this case study, so we gave them this 1 week skill sprint, got them out of the mud, and gave them a very, very simple pattern. And yeah, we got them up and running. It worked very, very well. So let's talk a little bit about Google Cloud Platform and Amazon Web Services. I've also got Azure here. And I think Azure is 3 raccoons in a trench coat pretending to be a cloud provider. But let's just talk about Google Cloud Platform and Azure for a little bit. Google Cloud Platform and Amazon Web Services. So basically, as I've said, Amazon Web Services is annoying and difficult, and I still don't understand why. I don't understand why I need to have third-party tools for managing Amazon Web Services. I think it's because they have a lot of legacy. I guess it was like the first generation of cloud, fair enough. But they haven't really evolved things. And you see with EKS, for example, that they still didn't sort of finish the job. You still needed to use third-party tools to deploy Kubernetes. There's still a job role there. So I think with Amazon Web Services, what they've done is that they've what Amazon Web Services have done is that they've created a role, they've created a job within an organization, and this gives them a vendor lock-in. So if you think within larger organizations, they're going to have probably quite a few people who are SRE, DevOps engineers, and their job is to make Amazon Web Services consumable by the organization, which is crazy because Amazon Web Services cost 10 times more than, it's really expensive. And so it's really weird that it's so difficult to manage, that you need to have this role within your organization to manage infrastructure from Amazon Web Services. And I think this is just them a way of like it's the same way that SAP has SAP consultants, I think. SAP has, it's very, very difficult. I don't know if anybody's ever done an SAP project. It's ridiculous. You need to have a legion of SAP consultants, and bigger organizations will have these consultants in-house. And it's the same with Oracle or any of these big TIBCO, SAG. You really need to have consultants who know what they're doing. It's complex. It's very, very difficult. And they're still kind of like quite old school. So what Amazon Web Services, I think, have done is sort of maintained this old school attitude of vendor lock-in, and they've pretended it's modern, and they've kind of got away with it, which is really fantastic. And they are the dominant market player, and it works, I think. I don't think it's because of the quality of their services. Google Cloud is a far better cloud platform. It's directly consumable by developers. It's much more sensibly set up. Everything comes with good defaults. It's much easier to use. It's faster as well. And it works much better. The interface design is much better. Like literally the Google Cloud interface is miles better than Amazon. It's much easier to use, much less confusing. But it's nowhere near as dominant as Azure. Nowhere near as dominant as Amazon Web Services. So yeah, it's kind of weird. I'm very, very confused. Well, my idea is that Amazon Web Services are doing this vendor locking thing. I don't know. Anyway, and then we come with Azure, and I mean it's been quite some years. It's been about 7 years since I last touched Azure, and it was a nightmare, and I've avoided it like the plague ever since. But I'm ready and willing and able to go back into the world of Azure if anybody's willing to pay me to do so. So getting back to Darwinist, and again, so Darwinist is, so this is basically my modus operandi now. I don't know whether Darwinist is really a company anymore. So basically Darwinist was, or rather I am, providing technical consulting in the form of educational outcomes. So this is really about how do we build capability within a organizational team, and this is the most important thing. I do not want to be I do not want my clients to be dependent on me in any way. It's a very, very difficult situation to get into. And so when I work with clients, it's really, really about building capability, and that's the most important thing. I do a little bit of taking on a certain amount of tasks, but it won't be for very long, and I'll be looking for someone to offload that to really, really quickly. It's all very, very much like on-the-job training. So all of the work that I've been doing over the past 4 or 5 years has really been about giving people on-the-job training, taking this apprenticeship model and applying it within the IT sector, and it works. Again, I'm not about creating a dependency. I think all dependencies are generally unhealthy. And this is most important, is that this really, really helps with employee turnover, because one of the main problems that you have as a software developer is that you receive very, very little investment as an employee, because nobody knows how to invest in technical employees. And so you have no real way of progressing. So you always have to if you want to work with new technology, if you want to do new things, you always have to switch companies, which means that as an employer, you've lost this very, 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 you've lost this talent, and backfilling that hole is incredibly expensive. Like getting a new person in, getting them trained up, like somebody like a talented engineer walking out the door is really awful, and you can prevent that happening by providing effective upskilling, by providing effective progression, career progression. And that's something that I've been helping a lot of my clients do as part of skill sprints, as part of capability cultivation, is upgrading and, and also designing new roles for people. If you're introducing a new set of technologies, there's also a set of job roles around that. What are those roles going to look like? And how are we going to design those roles so that they're jobs that people want to do for a long period of time? And also within those roles, how are they going to progress within that role? What are the goals what are the goals for the roles, let's say? So these are technologies that I've worked with. I keep the Azure one on there, but it's very old now. I still don't know if it's apparent. So yeah, Python is by far so it's a lot of Kubernetes and a lot of Python in my world. I work a lot with Git as well, doing a lot of Git training. Actually, that's been really, really fun, and that's been using Git's been really. I found Git's really, really useful for getting less technical people into software development. And that's often the blocker as well. So the thing that's preventing less technical people from contributing, the main thing that's preventing less technical people from working with more technical people is generally around Git. And it's annoying and difficult to teach, and always, as we all know, Git's always trying to kill you. But I've done a lot of really, really fun work with Git. So the work that I've been doing is really companies that need external support with doing new things. That's broadened out a little bit now. Again, Darwinist as a company, the whole skill sprint thing worked really, really great, but the amount of energy that I had to put into business development was just exhausting. So I ran out of energy with it. So now I'm kind of applying these principles to sort of a more I'm applying these principles that I learned during this time to sort of all of the work that I'm doing nowadays. One of the most important things is about time to first value. And so, for example, if you're starting to work with a new technology and you're not getting value out of it literally within the first month, have you made the appropriate decision? If you're not able to get a rapid time to first value, something's probably wrong. If you're investing in a new technology, and you're not seeing it delivering something to the organization within a very, very short period of time, I think that you need to really reconsider what you're doing. If that time to first value is longer than 30 days, really think about what's going on. And that's all from me. And I don't know how much time I took for that. How was I?
Perfect with the timing. We have still 12 minutes left. So thank you very much. That was excellent timing and great insights, and probably some of the items you mentioned probably will open a kind of worms for discussions like which one is better, AWS and Azure, and IAC, yes or no.
I'm just flinging mud at them. It's not a good discussion, I think. I mean, the thing is, it's also not interesting. It's also not an interesting discussion about what is better. It's a case of what have you got. Most organizations have made a decision towards Amazon Web Services. They've made a decision towards Google Cloud, and you're not going to be able to affect. I mean, maybe if it's really bad, you can affect that decision, but why bother, really? What's really, really important to I mean, they're all reliable, right? And that's fantastic. But what's really, really important is understanding what they are. And if you understand the nature of these beasts, then if you understand the nature of them, if you understand where the pain is, then you're going to have a much better time. If you go all in on Amazon and I mean, it's the same with anything. If you use all of their proprietary stuff, then you're locked in, you're stuck, and it's expensive and difficult and annoying. If you try and avoid this footprint, it works great, and it really, really it does. It's completely reliable. I sleep well at night. But it's just understanding the nature of the beast. And it's like, also, if you're starting a new project, if you're starting a new thing, you can think, well, do we really want to have, so for example, you can say, well, we're a large corporate, we've got these DevOps engineers there, and maybe we have a reason for doing it, because maybe they do some kind of like security type stuff as well. Most people are quite wise to how Amazon works. In my experience, they're kind of like, yeah, we know how it's working, but we keep it like that for reasons. We have our reasons. And Amazon also do have, these different cloud providers. They also have, a different mix of technologies that are available. And so if you're doing more Amazon-y stuff, if you need those Amazon, you can use them and then use that. But it's more just about understanding the nature of the beast, really. But they're all reliable, apart from Azure. But maybe it is reliable now. I don't know. But it wasn't 7 years ago. So I don't know where it's now.
Lovely.
Any questions from you? Yeah.
No questions for me. It's just for everyone watching this after our stream ended. Please drop your questions in Discord. And Andrew, I think you're also joining the community. So if anyone has continuous questions, wants to settle the debate on the cloud provider, so let's go in there and chat. And thank you all for listening.
Oh yeah. So just one question was from my side. Then you about the technologies. Also for you, of course, it's hard for you for your own knowledge, because you're doing the consulting. You also have this what you showed in the last slide, the technologies you support. So it means that this is also the scope. You probably won't. I mean, to be scalable, you also have to acquire the knowledge for yourself. So it's probably the scope. And then somebody comes in with a new technology that isn't on your set. Is it also are you going to skill sprint yourself?
This is actually a project that I'm doing. It's actually coming. It's actually worked, but it's been horrific, and this has been so hard. Which has been around Kinesis, Amazon Web Services, Kinesis, and event streaming and Lambda. This has been rough, and this has been kind of extreme. So there are situations where I'm having to learn things, and the thing is as well is because I have to always be one step ahead as well. So I have to be able to anticipate what's the client going to want to do with this thing that I barely understand. It did work out rather well, but it is incredibly challenging, but really fun as well, is keeping ahead of people. But what's important as well is that most organizations, they can only go at a certain speed. And I've noticed that if you try and push people too hard, so doing a skill sprint, for example, is one thing. We're going to do a week. We know what we want. Bash, let's get there. But for longer term stuff, you have to work at the speed of the organization. And if you try and push them too hard, it doesn't generally end very well. So you generally have time and space. So you're working furiously in the background and working to their cadence, which is generally it's generally slower. But it is manageable. But Kinesis was really difficult, and generally understanding how these event streaming platforms work is pretty spicy. Fun though.
Nice. So you managed to upskill yourself.
Yeah.
Right. Thank you so much, Andrew, for joining us today. We are very good with the time. I just want to make some closing notes for our next meetup. So first of all, if you have questions, join us on Discord, as Seb said, and then the next session will be on September 21st, and it will be around policy as a versioned code, so embracing continuous policy management. And you find this all on our website as well as on our meetup.com community website as well. Thank you, Andrew, for being our speaker today. Thanks, Sebastian, for being the co-host as well.
Thank you, everyone.
Thanks, everyone, and have a good day.
Bye.
Bye.